Hello, General Biology, and welcome to Section 3.4 in the Chapter 3 screencast series. And we're going to be talking about the cycles of matter. Okay, so you remember I said that the biosphere is a closed system and that all matter is recycled within that system, that we only really lose heat energy out of the system. The heat energy changes, it cools, it changes down. So being a closed system means that, like we had talked about with plants, carbon dioxide, which living systems give off, which decomposition gives off, erosion gives off, volcanic activity gives off, our cars, the way we heat our homes. Carbon dioxide is given off through a lot of processes. And if we kept just putting carbon dioxide into this closed system, sooner or later it would become so toxic that organisms would start to die, including us. So in order for the carbon dioxide levels to remain low enough to enable the survival of organisms, we have plants, and plants recycle that carbon dioxide. So it changes that carbon dioxide along with water into usable energy of glucose. So that's what we're going to be talking about in this section. I need to tell you that this section's a little bit more difficult than the first three sections that we talked about. We are going to have the diagrams that you're going to see here. You're going to see them on tests, so you need to be able to familiarize yourself with the diagrams. You're going to hear them here on the screencast, and we're going to like a little bit of redundancy, and we're going to go over them again in class so that it really sends it home about this recycling process. So our key concepts in this section are: how does matter move through the biosphere? And we're going to see that unlike the one-way flow of energy, matter is going to be recycled within and between ecosystems. So it's not just going to happen isolated within one ecosystem, it's going to be happening between all of the ecosystems. Again, that interconnection that we have in order to maintain life on the earth. It's an interdependency, what we've been talking about all along. So here is recycling in the biosphere, and we call recycling in the biosphere biogeochemical cycles. And biogeochemical cycles, when we break down that word, bio means living, geo is the geological, the terrestrial, the ground, the land, the soil, and then the chemical part are the reactions that take place. And as you can see by the illustration here, we've got a flow of energy that comes in, and then it recycles with that water wheel, and it continues that flow of energy the way that the organisms can use it. So when we go back and we think, okay, what does this apply to? One of the things that we had learned in Chapter 2 was the law of conservation of matter. And the law of conservation of matter tells us that matter is never created or destroyed. It's just going to change form. And doesn't that make sense with a little bit of what we've been talking about so far? Because aren't we telling you, and haven't I been saying, carbon dioxide along with water is going to be changed into this molecule of glucose, and we're going to get some oxygen with that. And if I had written this equation properly in chemistry, it would take actually 6 molecules of water, or carbon dioxide, 6 molecules of water in order to make 1 glucose molecule and 6 molecules of oxygen. So when I look at this, remember what happens on this side of the equation is going to be equal to that side of the equation. So if I count up how many carbons I have 6 carbons there, I have 6 carbons there. If I count up how many oxygens I have 6 times 2, so I have 12 oxygens here. I have another 6 over here, so I have 18 oxygens. Do I have 6 oxygens here? Yes. And do I have 12 more here? Yes. Does that equal 18 like that does? It does. So we've got an equal amount on that side. And then the last thing is I have 12 hydrogens here with this combination, because 6 times 2 is 12. And I have 12 hydrogens here. So I am not creating anything new. I'm not destroying anything. I'm just rearranging those chemicals, and I'm coming out with glucose and oxygen. And that's how the law of conservation of matter is going to apply to this. It's not created or destroyed, it's changed, it's rearranged, and that's what we're seeing. So we will take a look at this video clip in class. So the main purpose of these biogeochemical cycles is going to recycle those nutrients in the biosphere. And it's going to do this through biological processes like photosynthesis, like cellular respiration, and the activities that are performed by living systems. So these processes that we're talking about are going to involve eating, because we've got to digest and break down those materials. They're going to involve breathing, because we need to take in that oxygen and we need to exhale the carbon dioxide, because the plants need that carbon dioxide. It's going to involve burning food. Do you burn your calories? Does your metabolic actions that you have going in your cells help to burn and break down those calories? And it's also eliminating waste products. What goes in has to come out and flush, okay? So that's what these biological processes contain. The geological processes are going to include things like volcanic eruptions. They're going to involve the formation and the breaking down of rocks. So erosion is going to be a part of the geological processes, and compacting under high pressure and forming these rocks. There are going to be major movements of matter that's going to happen within and below the Earth's surface. So the moving of plate tectonics and earthquakes, the molten lava that is under the Earth, and the molten iron that we have under the Earth. The geological processes are going to involve, when water runoff happens, and that kind of goes along with erosion happening. And that's going to be the geological processes of the biogeochemical cycles. And then the chemical part is kind of like a combination of chemical and physical processes. And this is where we're going to get the formation of clouds and precipitation, the flow of the running water, the action of the lightning. All of these involves some sort of chemical energy or chemical reaction that's going to be happening. And changes, we're going to see chemical changes that's going to go on, like converting the carbon dioxide in water into glucose and oxygen. So there's a lot of things that play a role that affect these cycles, and one of those is human activities. We are the biggest number one thing that impacts our biogeochemical cycles, not only on an individual scale, but on a global scale as well. We're mining, and I think you would be horrified at the type of mining that we do. We do mountaintop mining, where we cut off the top of glorious, beautiful mountains for coal. We do open pit mining, where we go into a community and we just dig this horrid, ugly, open pit, and it has a pool of raw sewage that if a bird lands in it, it's going to die instantly, and we leave these pits abandoned. We do regular drilling, hydrofracking. This summer I got to actually see hydrofracking in person. And hydrofracking is where they take water and sand and they force it underground, about 10,000 feet underground. They break the shale that's holding the Earth's crust, and they extract natural gas from it. And that natural gas contaminates our aquifers, and that's where we get our fresh water from. So human activity really impacts our ecosystem services. We clear land, we build, we farm, we burn, we cut down the forest, we manufacture, we use fertilizers and chemicals, we pollute. All of that is going to impact these cycles of matter. So the biogeochemical cycles are there so that matter can pass and they can go through and be used over and over and over and over again in the process, so that we don't have to continue to bring in new resources. So we're going to start with the water cycle. The water cycle does cycle through the biosphere. It continually moves between the oceans, the atmosphere, and the land. And sometimes it's outside of living organisms, and sometimes it's inside of living organisms. We have moisture, and when we sweat, that moisture can evaporate off of us. So the same thing with animals, although I know dogs don't sweat, but they do through their tongue, just not through their skin. So I am going to erase this screen. Give me just a minute here. Oh, I can't erase the screen. Never mind. It's going to stay there. We will watch the video on the water cycle. I think you're all pretty familiar with the water cycle, but let's go over it. So the ocean is going to hold, ocean lakes and streams are going to hold about 75% of the water that's on Earth. And the ocean water is salt water. So that makes up about 60% of the water, and the other 10% is fresh water. And about 1% of that fresh water is water that we can drink. So what happens with that is, as the energy from the sun heats up the Earth's surface, it can heat up the oceans or it can heat up the land. It causes water to evaporate, meaning that that water is going to turn into the gas. The further up that water gets from the Earth's surface, the colder the atmosphere is. So what happens is that gas begins to condensate. It condenses, and it forms tiny little water droplets. And those tiny little water droplets are going to form our clouds. That's where our cloud formation is going to come from. When the clouds get super saturated with water, then that water is going to fall back down to the Earth's surface in the form of precipitation. So it can be snow in the form of snow as a solid. It can be in a liquid as rain. And we can even get it in the form of steam as humidity, as we felt some of these really hot, humid days this summer. So when the water comes back down to the Earth, it's going to run off. It's going to run off into lakes and streams. It's going to run off into oceans. And it's going to seep into the ground and get into our aquifers and making our groundwater. And this is the water that we tend to drink, that we take up and we drink. Now, another way that the water gets up into the atmosphere is by a process called transpiration. And this is when, again, the sun heats down, but it gets the moisture from the plants and from the trees. And again, it rises up as it gets further away. It cools down and condenses, and it forms the water droplets, making the clouds, and then that comes back in the form of rain. When the water gets pulled out of the ocean, it separates it from the salt and makes it fresh water, and that's where we get our freshwater supply. We're running out of time here. I want to say a few more things about water, and then We'll continue in the next screencast.